What's a hypothesis? A statistical hypothesis is a claim about the value of the mean or proportion of a population. To decide if the claim is true, we go through the steps of the hypothesis testing procedure. In the first step, we state two hypotheses, the null hypothesis and the alternative hypothesis. That's what we're going to be doing now. We're going to be doing step one, which involves setting up two hypotheses. We're going to go through the entire hypothesis testing procedure at a next lecture, in the next lecture coming up. And after going through the hypothesis testing procedure, we'll come to a conclusion and we'll basically make our decision. So the beginning part, the setup of the null and alternative hypotheses. The null hypothesis is symbolized by H subscript 0. I may say HO for this. This hypothesis represents the current assumption about the population parameter. It's assumed to be true until sufficient evidence is obtained to warrant its rejection. The alternative hypothesis H subscript A, this is the counterclaim. Usually this is what we want to show is true by coming up with sample results which are significantly different from what we should get if the null hypothesis is true, like evidence in a trial. So our null hypothesis is going to state something like Gestamax doesn't increase pregnancy lengths. Gestamax produces pregnancy lengths that are just the same as the regular population. And the alternative would be that Gestamax increases pregnancy lengths. And that's what we want to show. We want to show that the chance of getting results produced by Gestamax are significantly different from what we would get if we just simply believed that the population parameter was 266 days. So our null hypothesis, symbolized by H sub O, is a claim about the population, and it's assumed to be true unless proven not true. That's like saying the defendant is not guilty. So we make this assumption throughout the process. The alternative hypothesis, H sub A, is the counterclaim about the population. It's what we are trying to disprove about the claim. So let's set up the null and alternative hypotheses for the following. A college newspaper claims that full-time college students work a mean of 20 hours a week. A marketing professor who believes this claim is too high decides to conduct a study to test the newspaper's claim. Okay, you have a population parameter, 20 hours per week. This is a population mean. Then we have a marketing professor who believes that 20 hours is too high. So the setup of the null and alternative hypotheses should be like the following. HO should state the population mean number of hours that full-time college students work is 20 hours per week. We always want to start the null hypothesis with the words the population mean. Then we're going to state what the variable is, which in this case is number of hours that full-time college students work. And then we're going to state the value is 20 hours per week. Symbolically, we're going to use mu equal 20 because our population mean is mu and we're stating that it equals 20. The alternative hypothesis is going to state the population mean, again it's going to start with the words population mean, then the variable, number of hours that full-time college students work, and then the counterclaim is less than 20 hours per week. So the counterclaim is HA. And symbolically we have mu less than 20. When we make hypothesis tests regarding population means, we're going to start HO and HA with the population mean. And symbolically it's always going to involve mu. mu equals 20, mu less than 20. When we create hypothesis tests for proportions, we're going to state the population proportion as we have in this next example. A national department store chain has determined that in previous years, 60% of its customers used the department store's special holiday credit card to make Christmas purchases. This year, because of changing economic conditions, the department store management would like to determine if 60% is too low. So we're going to state the null and alternative hypotheses. H sub O, the population proportion of customers who use the holiday credit card is 60%. Okay, so we're going to start the words with the population proportion because 60% is not a population mean, it's a population proportion. And symbolically, we're going to state that P equals 0.60. Now, the counterclaim involves the management would like to determine if 60% is too low. So the management expects that the figure should be higher than 60%. So we're going to state our alternative hypothesis as follows. The population proportion of customers who use the holiday credit card is more than 60%. Because if they believed it was too low, then the belief is that it should be more than 60%. And then symbolically we say P is greater than 0.60. Okay, so this is how we set up the null and alternative hypotheses for a population proportion test. And the previous example showed you how to set it up for a population mean test. That's going to carry us through the examples from chapter 11 when we get to the next lecture. Directional alternative hypothesis. A directional alternative hypothesis is an alternative hypothesis that considers only one specified direction of difference away from the value stated in the null hypothesis. And this is what we mean by that. If we look at the alternative hypothesis and we use the words less than or greater than, then we have a directional alternative hypothesis. So in example 10.3, the alternative hypothesis used the words less than 20. And in example 10.11, the population proportion is more than 60. So the use of the words more than and less than, or more than and greater than, it could easily substitute greater than with more than. The use of those phrases indicate that we have a directional alternative hypothesis. In this class, we're only going to be using directional alternative hypotheses. There is a non-directional alternative hypothesis that is shown in the textbook, and instead of less than or more than, the non-directional alternative hypothesis will state not equal to. Okay, and you'll see some examples like that if you take a look at the textbook, but you can disregard those examples because I'm not going to be testing on them. If you want, of course, if you want to know about them for your own understanding, feel free to look at them, but I'm not going to be testing on them in this class.